Good everyone, and welcome back to my YouTube channel. I'm one of the best educational consultants. Thank you so much for watching my video, sharing my video, and giving my video a thumbs up. I really appreciate your efforts. Thanks, thanks, thanks. Okay, now in this video, we're going to continue with Jamb syllabus on measurements and units. Now we're going to talk about the dimension. I've told you what dimension is all about. Dimension is the expression of the quantities into fundamental quantity. When you are talking about dimension, we're talking about when you are breaking down all the quantity they give you into fundamental quantity. And that quantity we are talking about is the basic fundamental quantity. So dimension is all about anyone they ask you in Jamb, you break it down until you get length, mass, and time. You start breaking until there is nothing like any formula again, until you get length, you get max, length, and time. So now see what Jamb will ask you. See the question, how the question will be. Let's start with the smaller one before I will show you what Jamb will ask you. Like now, let's start with this one. Let's start with velocity. Jamb will ask you, express this thing in the dimension of m, x, l, y. Express this thing in the dimension of m, x, l, y, t, z. So now they have given you velocity. Do you understand? So my brother, see what you do, my brother and sister. This is what you do. See what you do. Velocity. First of all, find the formula for velocity, which is displacement over time. They told you to find x, y, and what? Z. X, y, and z. So now we have the velocity, which is equals to displacement which is length. Displacement is the length. Remember I told you that displacement, length, distance, length, as well as radius. All over what? Time. So now look at the board. They told you to express this in terms of x, y, and z. You understand that m is x, y is what? L is y, and t is 0. Make sure you arrange it according to max, length, and time. You understand? Then we ask you this question. So what are you going to do? We have gotten length and time. So remember that dimension is all about breaking down until you get length, mass, and time. Had it been that we didn't get length, mass, and time, we start breaking them down. But now, because our main aim is to get length, mass, and time. Max, length, and time. But now velocity has directly given us length and time. Had it been velocity acceleration, had it been the actual acceleration, I will do that one. You will know it more and more. Now we are getting length and time. What we do? We say that therefore velocity equals to length over time, which is equals to L t minus 1. So this is the answer. But now they ask you to express this in terms of x, y, and z. So what are you going to do? You bring it down. Mx at the top, x is equals to 0 because there's nothing like m here. We didn't get m. There's no m. Are you getting me? So x is equals to 0. Then ly, y is equals to 1. Are you not seeing it? 1. Then t, z is equals to minus 1. So our answer is 0, 1, minus 1. Do you understand? So are you not seeing it? Are you not seeing it? You take what they have at the less to power because we don't have m. So m, that mass, s is 0. We don't have it at the answer. We have only length. So length is less power 1. Is 1. Then time is less power minus 1. Are you not seeing it? So zeta is 1, minus 1, y is 1, ys is 0. So the answer is 0, 1, and minus 1. So are you getting me? So dimension is when you express the formula into mass, length, and time. So Jamb will ask you this question like this, or they will ask you what is the dimension of velocity. So the dimension is length. They can ask you like this, or they can ask the question like this. Do you understand? So the dimension is this, dimension is this. Then if they ask you like this, the answer is this. Do you understand? So when you break it down, if they ask you like this, they are talking about the raised to power, what it has at the power. Do you understand? If they ask you like dimension, this is the dimension. Dimension means to break down a quantity onto the length, mass, and time. Let's do one. We want to do like 2 or 3. We go for another one. Let's go for a cell election. Remember, you are going to express it in x, ms, ly, tz. So acceleration, the formula is change in velocity all over time. Remember that dimension told us that once you have not gotten mass, length, and time, you start breaking it down. You start breaking it until you get it. You understand? So now we have only time. We need to break down the velocity. We need to break down the velocity. Are you not seeing it? Are you not seeing it? Are you not seeing it? We have only time as the fundamental quantity. Dimension is all about breaking down the formula to get mass, length, and time, the major fundamental quantity. So now we have this. What are you going to do? You break this one down. Change in velocity will be displacement over time. So now acceleration, our acceleration will be equals to velocity is what? Displacement, which is equal to length. Everything over, you bring down this time times time square. Do you understand? Because remember that acceleration itself is changing velocity over time. So now because we have not gotten mass, length, and time, we now break that velocity until we get fundamental quantity. That is what we are talking about by dimension. When you break it, we now get displacement over time. We now bring this time again. Do you understand? So now we have something like acceleration is now equals to length over time square, which is equals to L t minus 2. L t minus 2 raised to the power minus 2. Do you understand? So now, this is the answer for dimension. But now we are talking about M, X, L, Y, T, Z. Now we say that our M, X equals to 0. Our L, Y equals to 1. Then our T, Z equals to minus 2. So therefore, our answer is 0, 1, minus 2. Remember this formula. You are breaking down everything until you get mass, length, and time. So that is dimension. That is dimension. You are breaking everything down until you get this. Until you get this. Once you haven't gotten it, you start breaking down. You start breaking down. You start breaking down until you get mass, length, and time. You understand? You understand? So this is the answer in terms of mass, m less power s, y. So we don't have mass. We didn't get it in the option. So you are breaking. There is nothing like this. This thing is very simple. You start breaking down. You start breaking the formula. You start breaking the formula. Do you understand? So now let's go to force. Force is equals to mass times acceleration. So remember that when they give you this for dimension, remember that what I told you, that when you break the formulas, you are trying to make sure that you have mass, length, and time. So now it's only mass we have here, but acceleration is not a fundamental quantity. So we now start breaking it down until we get fundamental quantity. So now break it again, because you're talking about dimension. Force now is equals to mass times change in velocity all over time. Remember that we have gotten our time and mass, remaining change in velocity. Dimension is breaking down until you get length, mass, and time. You break everything down. You start breaking the formula, breaking the formula until you get mass, length, and time. So we still have velocity. We need to break it down. So we need to break it down. Until we get what we want. So if we break it down now, we break the velocity down. When we break the velocity down, what are we going to get? Is equals to what? When we break it down, we get displacement, which is equivalent to length all over time. So now we have gotten what we want. When we break it down, we now have force equals to mass times displacement everything over time. Do you understand? Time times time. We still have, remember that we have gotten everything now. So what we have now is force equals to m. Displacement is what? L all over t square. So remember what I did. I told you that when they give you force, when they give you something to find out in dimension, what you will do is that you start breaking down. When you break it down, if you break this one down, you make sure that you get everything you are getting is the fundamental quantity, which is mass, length, and time. Now we are breaking this one down. We got mass and acceleration. So when we get acceleration, we now break acceleration to get all these things. So what we have now is max L T minus 2. Remember they told you to express this in mx Ly T Z. So our m now is x is equals to 1, L is y is equals to 1. You're looking at the upper power. Ty is Tz is z is equals to minus 2. So our answer is 1, 1, minus 2. Are you seeing it? So when you are breaking it down, as force, you said that force is mass times acceleration. Our force now is mass times acceleration. You have gotten the force. So what are you going to do again? Your main aim now is for you to start breaking it down. Until you get mass, length, and time. We now break that velocity. We break acceleration, because acceleration is not a fundamental quantity. We get this change in velocity over time. So we are getting mass and time in the equation. So we need to break down the velocity again. We now break velocity, which is displacement over time, and displacement is the length. So now you getting me is the length. So we are getting mass, length, and time. So now this is the what we get from there. So now you know that this mass, when anything that is dividing, when you cross it, it become raised to power minus that thing up. So raised to power minus 2. So now remember what I told you to express it in x. So what is x to the power? M here is 1, y here is 1, this one is minus 2. So x is 1, 1 minus 2. You understand? Y minus 2. Hope you understand it. Let's go to gravitational force. So then we ask you this question. So this one is all about knowing the formula. Know the formula. Once you know the formula, you will like to it. Let's go to gravitational force. Gravitational force is equal to gravitational constants mass 1 mass 2 all over reduce square. So they told you to express this in mass square Ly T Z. So what are you going to do in this thing now? They told you to find the gravitational constants. So you cross and multiply. When you cross multiply, we have F gravitational mass R square equals to G MA MB. First of all, you cross multiply to make this man the subject because they told you to find this man gravitational constant. So you have cross multiply and see this. So what are you going to do? You divide it by this. So what we get now is gravitational force R square over MA MB equals to G. Remember that this is the formula for gravitational force, which is equals to mass 1 times mass 2 over R square. But you put gravitational constant. They told you to find the gravitational constant and express it in less of M raised to the power S, Y raised to the power this, L raised to the power this, and T raised to the power Z. So once you make gravitational constant the subject formula, from here you are making it the subject formula. What are you going to do? You now start breaking it. Because now we are getting mass. Radius is the length. It remains only the force. You need to break down the force. Before you get everything you want. So let's now start breaking down the force. So what we say now is gravitational constant is equals to force is mass times acceleration, because force is not a fundamental quantity. Remember that our rule states that you must break down till you get the fundamental quantity. So we get now, which is mass, which is M times acceleration times radius square, everything over MA MB. So now we have gotten mass. Acceleration is not involved. What we do, first of all, cancel mass. We have only one mass. You cancel one mass and cancel this mass. Remember now, we still have acceleration. We need to break it down because acceleration is not a fundamental quantity. The thing is, you start breaking until you get the whole fundamental quantity. That is dimension. So now, when we break it down, we now have that G is equals to acceleration is change in velocity, everything over time by mass B. Remember that we still have R square. We need to break down the velocity because velocity is not a fundamental quantity. When we break it down, we get displacement over time. Now we have gotten everything. So now we break it down again. We now have displacement, which is equal to length times R square all over time times mass. Remember this? Look at the board. They give you gravitational force, which is equals to gravitational constant times mass A mass B over radius. So what will you do? You start breaking down. Understand? You start breaking it down. When you start breaking, you break it until you get length, mass, and time. Until you get length, mass, and time. When you see that we break it, because they ask you to find the gravitational constant and express it in terms of mass raised to the power s, length raised to the power y, t raised to the power z. So now you cross multiply to get to make this man subject formula, the gravitational constant, which I did here and got it like this. After that one, after getting it like this, I now say I'm making a subject formula here. So now G is this, and now break force, because force is not a fundamental quantity, it's a derived quantity. We need to break it to become a fundamental quantity. So now we get a formula for force, which is mass times acceleration times reduce square, that reduce all over mass 1 mass 2. We now cancel one mass from the mass of the force and the mass of this one. So after that one, we say that acceleration is not a fundamental quantity, it is a derived. We need to break it down. We now break it and get change in velocity over time times r square times b square. Now, as velocity is not a fundamental quantity, you need also to break it down until you get the whole fundamental quantity, which is now displacement times time. Velocity is displacement over time. Velocity displacement over time times r square. This r square all over, you bring out this time and bring out the mo there. Do you understand? So it's all about breaking. Just know formula. Once you know formula, you start breaking until you get mass, length, and time. So now let's continue. So the G now is equals to, this one is length, this one is r square. R square is also length all over t square mo b. So now we have length. This is length is now into 3 all over t square m. So what we have now is L cube t raised to the power minus 2 and m raised to the power minus 1. You put it in order because it is mass, length, and time. You put it in order. So now we have G is equals to max raised to the power minus 1, L raised to the power 3, and t raised to the power minus 2. That is the dimension. Now we say that x is equals to minus 1 as y is equals to 3 and z is equals to minus 2. So our answer is 1 is minus 1, 3, and minus 2 for that one. Do you understand? So now when you look at these things, the thing is talking about how can you break down everything until you get mass, length, and time. You will do this one by making sure that when they ask you this question, first of all, find the formula of that thing. If you find the formula, if the formula is not max, length, and time, what we do, you start breaking, you start breaking, you start breaking it. When you break it until you get max, length, and time, when you are getting your mass, length, and time, you now equate it to normal displace. You equate it to this. When you equate it, you check the powers. The powers are representing x, y, and z. Do you understand? So your mind should be that dimension is breaking down a formula of any derived quantity until you get length, max, and time. So dimension are expressed in terms of max, length, and time, in terms of fundamental quantity. Do you understand? Hope you understand this. I know you've not failed Jamb again. It's from Jamb syllabus, so they'll say this question. Thanks so much for sharing my video. I really appreciate it.